So input so the relation between the input and the output is basically controlled by the system. So that's why it is called embedded controller. Embedded controller. It may be MC5 Arduino, anything. So the main purpose of the embedded system is by its sensor. Here input, here input, and the output either externally, any input is analogous to convert the basic the applications may be in like the car industry, like automatic feeding plant, automatic packing industry, even in your mobile phone, the embedded system. One of the main concepts of the embedded system is a real-time system design. A real-time system design means the inputs when you and to generate the output, it takes some time to process the data. So time is required to process the data and to generate the desired output. This time is vital part of any embedded system. If it takes more time, means the delayed system. Example of your delayed system I give you. Suppose you turn on your television. So it takes some time for display, it takes some time to figures everything to play sounds like that. So this is called the booting time, and the processing time means suppose you increase the volume. So when you press the button and it takes affected, this is called the process time. This time we plan in such a manner that means when the data change, it is important that how you write program for embedded system. So the programming technique is one of the major things to design, and in the desired output you have to write a certain algorithm, and by using coding and jumping into the process through our brain, and so in your algorithm it depends on the processor, and it varies from processor to processor, but the algorithm is the same. And many in many different embedded controllers, this algorithm may be varied, depends on the construction of the processor. Suppose in case of image processing, to process the image, for that purpose special kind of processor have to develop, like the Raspberry Pi. The Raspberry Pi is able to process that image. So suppose to on and off a LED, if you use the Raspberry Pi, which is cost near about 6,000 to 7,000 rupees, to simply turn on and turn off, which is also able by using rupees 90. NNC 51 is near about 90 to 170 rupees. So the selection of the controller is also important. How you select the controller? The first thing, you have to list your requirements, that those are my requirements, and this requirement is low cost, means it not depends on the performance, it depends on the type of processing. I mentioned that if you use the Raspberry Pi to simply on off of any microcontroller, it is costlier, means your design is not cheaper. Those who design using 890 51. So first you have to select that which model solve your problem. It may be 890 51. For image, you can use the Raspberry Pi. For other information, other huge information, you can use the on-board PC. On-board PC means the single board PC, which is only using the processor, and that processor is capable to process the large, huge information. So the selection of the microcontroller or selection of the processor is also important part. Another thing is the speed of the microcontroller. The speed of a microcontroller is essentially requirement when to design the real-time system. The real-time system is, we call it is RTS. RTS. That is a real-time system. Is basically one kind of RTS is one kind of embedded system which process the data, means its processing speed is very fast and it takes minimum time. Obviously, if it is fast, then it's capable to process the data with minimum time. But one thing you remember that the processor work a single work at a time. But in many operations, it requires that the multiple work you have to use the multiple processor, and this processor able to communicate with each other, and they are able to separate the tasks among them. Separate tasks means suppose 4.53, 1.2. So one processor is assigned for to calculate this part, and another processor assigned for to calculate this part multiply. So after that, by using the simple addition law, they provide the output. But the user not bother about that which processor, that is processor 1 or processor 2, perform this task. If processor 1 is engaged, then the processor 2 complete the task alone. Here the pipeline concept is appear. It is not necessary that the processor, a single processor, able to work, or the multiple processor able to work. It basically depends on the applications and the processor construction. In our course, we also learn about how the multiple processor work, how the tasks are divided, the concept of pipeline, the different processor, their functions, their programming technique, I think that all of you know about the 8085 microcontroller, which is a bigger size where a processor part and the other the bus. This bus and relevant information that these are the location of your data, or this should be stored at that the information. And another big terms of microcontroller. So memory part, control part, and the other peripherals are miniaturized and simplified, and it's stored into a so 805 for commercial use, and you know that your laptop previously or computer previously 32 bits, 16 bits, 32 bits, now it is 64 bits, like that. So the number of bits means the accumulator capable to process that amount of bit in a single instruction or single time. Means in a single clock, it is able to process 32-bit information. Okay. At a single clock, it is able to process 64-bit data. Means at a single time, it is able to work on 64-bit data. The number of bits means its performance is also increased. How? Means at a single time, it processes a larger amount of data. The disadvantage is power. Power means to provide the power of every bit of the accumulators, the number of chips, number of the memories it consumes the power. So at a whole together, the power requirement is increased. It is another disadvantage of the microcontroller. If a system consumes the large power with respect to the another system, it may cause the power failure. Basically, these are all the standalone systems. So if the system is failed, the whole work is failed. Suppose you play with a robotic car, that robotic toy, and suddenly your battery is dry. What happens? That's one thing. And you take the example of your mobile phone. So we try to increase the uh, power of the battery. The disadvantage of a large battery is that it increases its weight. So the system weight also increases. So this is the disadvantage. And another, to improve the system in such a way that it requires less power. So there is a trade-off between the system performance and the power requirements. In case of the VLSI circuit, you read about the power in more details. So in our next class, we discuss about 89C51 microcontroller and its programming technique and the different applications. So that's all. Thank you.